So now we'll continue with the sets. So in the previous class we have studied the different types of sets. We have seen 4 different types of sets, and those were empty set, singleton set, finite set, and infinite set. Now we'll see some more types of sets. So in that, the first is actually the cardinal number of a finite set. Cardinal number of a finite set. So cardinal number is actually the number of elements of a finite set. Like suppose if we take any set, let's say A, B, C, D and E. So these are the elements of the set A. So cardinal number of set A is actually equal to 5. It means the number of elements that the set A has is actually known as the cardinal number of a finite set. This is what you mean by cardinal number. Now the next type of set is equivalent set. Are the two sets having the same cardinal number are said to be as the equivalent set. Like suppose if we take any set A and let's take the elements of A as A, B and C. In the same way, if we take another set B having the elements, let's say 1, 2 and 3, then A and B are the equivalent set because the cardinal number of A is equal to the cardinal number of B, and cardinal number is actually the number of elements that the set A and B has. So it means if the cardinal number of two sets are equal, then these two sets are said to be as the equivalent set. It means as in this example, so set A and B are equivalent set because they have the same cardinal number or they have the same number of elements. Therefore, these two sets are equivalent sets. Now we'll take next type of set, that is equal set. Now equal sets are the sets having same cardinal number as well as the same elements. Like suppose if we take the previous example of equivalent set in which we have taken set A as element A, B and C and set B has elements 1, 2 and 3. Then they are not equal sets, they are only equivalent sets. Why they are not equal sets? Because their cardinal number is same, okay, but their elements are different. Their number of elements are same, but their elements are different. So therefore they are only equivalent sets. They are not equal sets. Equal sets means having same cardinal number as well as the same elements. Like suppose if we take set A as A, B and C has elements A, B and C, and set B has elements again A, B and C. Then this A and B are said to be as equal sets. Why? Because definitely they have the same cardinal number as well as the same elements. Therefore set A and B are equal sets. Now we'll take next type of set, that is subset. Now subset means like suppose if we take two sets A and B, and if every element of A is there in B, in elements of B, then it means that A is known as the subset of B. Like suppose if we take set A as having elements 1, 2, 3, 5, 7, let's say these are the elements of set A, and if we take set B having elements, let's say 2, 5, 3, then B is the subset of A. B is actually known as the subset of A. Why? Because every elements of B are there in elements of A. B has the element 2, 3 and 5, and these elements are there in set A also. So therefore B is actually known as the subset of A. But A is not a subset of B. Why? Because A has the elements 1, 2, 3, 5, 7, and all these elements are not there in set B. B has only 2, 3 and 5. There B does not have 1 and 7. So therefore A is not a subset of B, but B is a subset of A. So as B is a subset of A, so we can write it as B is a subset of A, where this sign denotes equal to. Equal to means that it may be the possibility that every element of A and B are equal. Then also B is the subset of A. Like suppose if we take any set, let's say C, having elements A, E, I, and if we take other set D having elements E, I, A, then D is actually the subset of A because all the elements of D are there in C. and C is also a subset of D, because all elements of D or all elements of C are there in D. It means they both are equal sets. So accordingly, we have studied just before this that what are equal sets, that if both every elements of both the sets are same, then those sets are known as the equal sets. So therefore D and C are equal sets. So therefore we can write D as D is a subset of C. So we can write therefore it as like this, and C is also a subset of D. So we can write it like this also. Equal to means both D and C are equal, can be equal sets also. It means every element of C or every element of D will be there in C, and similarly every element of C is there in D. So both can be equal sets also. So both can be equal sets. So those equal sets are also the subsets of the original set. Like if we take the subset of A, then A also has one subset as having elements 1, 2, 3, 5, 7. So this is also the subset of A, 1, 2, 3, 5, 7. And every element of these two sets are equal. Therefore, we use the equal to sign, because these both are equal sets also. So therefore, we are using equal to sign, and this is also the subset of A. So therefore, we are using the sign of this subset. So in this way, we can denote that that the one set is a subset of other set. In this, by using this sign, we can denote this thing, that one set is a subset of other set. So as B is the subset of A, so we can write it like this. But if let's say B and A are not equal, or it means if B and A are not equal sets, means all the elements are not same, then we can also write it like this, that B is a subset of A. We can also write it like this. This shows that every elements of B are not there in, every elements of A are not there in B, but definitely every elements of B are there in A. So therefore B is only the subset of A. B cannot be equal to A. This denotes that B is only the subset of A. B cannot be equal to A means all the elements of A and B are not equal. So therefore they are not equal sets. So as they are not equal sets, so we can just denote it like this, that B is the subset of A. So only we can denote it like this, that B is a subset of A. So this shows that every element of A are not there in B. So B is only the subset of A. So this is what do you mean by subset. Subset means, so if we say that one set is a subset of other set, it means every element of one set will be there in the second set. If this is the case, then definitely we can say that one set is a subset of other set. And this is the symbol by which we can denote that every elements of A or every elements of A and B are equal. So therefore, we are using equal to sign to denote the equal set. And if we use this sign only, this means that the both cannot have all the elements same. But B has all the elements in A. So therefore, B is only the subset of A. So B cannot be equal to A. But if all the elements in the other set. So if this is not the case, then we cannot call them as a subset. This means B is not a subset of A. So this is what you mean by subset. Now every set is a subset of itself. It means, like if we take set A as 1, 2, 3, 5, 7, then definitely A has one subset as having all the same elements, that is 1, 2, 3, 5, 7. Like suppose if we have taken this as G is equal to 1, 2, 3, 5, 7. So A and G are having all the elements same, and G is actually the subset of A. So this means that every set is a subset of itself, and also the empty set. And also the empty set is a subset of itself. Like suppose if we take any example, in which suppose if we take set A as 1, 2, 3, of A are 5, this is one subset, then 1, then 2, then 3, 2, then 3, then 1, 2, then 2, 3, then 1, 3, then 1, 2, 3. So these are actually all the subsets of A. These are all the subsets of A. Because why these are all the subsets of A? Because if you take any of this or any of these sets, any one of these sets, then all the elements will be there in set A. Like if we take this subset, then definitely this subset has the element 1 which is there in A. Now if we take this subset, this subset has the element 2 which is there in A. Similarly, if we take any of these sets, then all these sets are actually the subset of A, because in all these sets every element is there in A, so therefore all these sets are said to be as the subset of A. In this 8 subsets, 1, 2, 3, 4, 5, 6, 7, 8. So there are 8 subsets of A. In these 8 subsets, this first set, that is phi set, and this last set, that is having element 1, 2, 3 as equal to A. These two sets, that is phi set and subset, that is 1, 2, 3. These two sets are known as the improper set. These two sets are known as the improper set. Why improper set means? Because improper set means that why improper set? We are calling them improper set because if we see phi set, this phi set means null set. This phi set is known as the null set. We have already studied this. Or empty set. Why this empty set? Because we cannot see phi here, but we need to take phi or null set as the subset of A, because one of the subset of A can be like this. One of the subset of A can be like this, that is, but that is not quite visible, so we cannot therefore consider them as the proper set. So therefore we consider them as the improper set. And this 1, 2, 3, why this is called as improper set? Because this subset is actually equal to the set A, that is original set. This subset is actually equal to the set A. So if we take this subset, then this is actually this subset and this A are actually the equal set, because all the elements of these two sets are same. So if all the elements of these two sets are same, and there is no such element which is different in these two sets, so these two are actually the equal sets. We have already studied this. Therefore, these two sets, therefore this set is actually known as the improper set, because all these elements are there in this. So therefore, this is actually the improper set, because these are actually the equal sets. So therefore, these two sets are considered to be as the improper set. And apart from these two sets, all other sets are considered to be as the proper set. So always remember this thing, that in every set is a subset of itself. Like we have taken this. So this set is a subset of itself, means subset of this A. So these two. So this shows that every set is a subset of itself, and null set is also a subset of every set. Null set means this one. This we have taken. This is a null set, or this null set. So null set is also the subset of every set. Always remember this thing, that every set is a subset of itself, and null set is a subset of every set. So these two sets in all the subsets of any set, if we take only these two sets, so these two sets are said to be as the improper set. And apart from these two sets, whatever subsets are there, all are considered to be as the proper sets or proper subsets. We also call them improper set or improper subset. So the null set and the subset itself is considered to be as the improper subsets. So because every set is a subset of itself, and null set is also a subset of every set. So null set and the subset itself is considered to be as the improper subsets. And apart from these two subsets, all other subsets are said to be as the proper subsets. All these are said to be as the proper subsets. So this is what do you mean by proper and improper subsets. And whenever we need to find out how many subsets are there of any set, we can easily find out by using this formula. So this is the formula for finding out number of subsets of any sets. So that will be equal to 2 raised to the power n, where n is equal to number of elements of sets. Like suppose if we have taken just example like A, in A we have taken the elements as 1, 2, 3, 1, 2, 3. So as A has 3 elements, so the number of subsets we can find out of A, number of subsets of A will be equal to 2 raised to the power 3, where n is the number of elements of set. So A has the number of elements 3. So therefore number of subsets of A will be 2 raised to the power 3 or 8. As we just got that A has the 8 subsets. We have just seen this. So this can be find out using, so accordingly we can find out how many subsets any set has by using 2 raised to the power n. So as A has elements, A has 3 elements, so therefore n is 3. So it means the number of subsets of A will be 2 raised to the power 3 or 8. Similarly, if we take any set having elements, let's say A, E, I, O, U, and if we need to find out the number of subsets of B, right, how many subsets the B have, then we can easily find out using 2 raised to the power 5, because B has 5 elements, so the value of N will become 5. So we can do 2 raised to the power 5. So 2 raised to the power 5 will be equal to 32. It means the number of subsets of B are 32. So in this way we can find out the number of subsets of any given set. And this is what you mean by proper set and improper set.